Hello class, this is your instructor, Miss Birchfield. In this little lesson, mini lesson, we're going to look at applications of radian measure. This is 3.2. And in this, we're going to look at what is called the arc length of a circle. If you remember from plane geometry, we know that the lengths of the arc are proportional to the measures of their central angles. So if we look at our circle over here, notice that S is our arc length and our radius is 1, and then we're going to let the angle that's formed by the two radii that intercepts that arc, we're going to let that be in radians. And setting up a proportion, we end up getting this equation, S equals R theta, where S is the arc and R is the radius and theta in radians is the angle that is formed. So we will use this formula here to determine arc length and other parts of a problem depending on what's missing. So the first examples here, we have a circle that has a radius of 18.20 centimeters. We want to find the length of the arc. So that's S, that is intercepted by a central angle that has the following measures. So in the first example, we have that the angle is 3 pi over 8 radians. So to find our arc length, we're going to use our formula, which says that the arc is equal to the radius times the angle. So we'll just do some substituting. We'll do 18.2, and we're going to multiply that by 3 pi over 8. Now this, you can just enter this in, even the pi, into your calculator and just get the decimal form, which is 21.44 centimeters. So the distance around that circle of the arc is 21.44 centimeters. To do the second example here, for an angle to find the arc length, we've got the angle in degrees. You have to change this into radians. So in order to use the formula, we need our angle in radians. So we are going to use our pi over 180, and this will give us an angle of 4 pi over 5. Plug this information into our formula, 18.2 times 4 pi over 5. All right, we're going to just get the decimal here, which will be 45.74 centimeters. So that is the distance, the arc length around the circle, given this information. The next example is involving the distance around a clock when the hand of the clock is 3 inches. So that's going to be our radius. And it says for each duration, determine the distance that's traveled, by this minute hand. So what is the distance traveled around this circle? So we need to determine, in 30 minutes, we know that a full circle is 2 pi. So 30 minutes, we know that 30 minutes is half around that circle. So our angle here that we will use, we will change for 30 minutes, that's going to be pi, which is 180, halfway around is pi. And we're going to just plug this information in, and we have 3 pi. Now it tells us to leave our answers in multiples of pi. So that means I'm not going to change pi to a decimal. I want to leave pi as an exact value. So the distance around that clock is 3 pi inches. Now to determine 4.5, so this angle, 4.5 hours, means 4 times around, 1, 2, 3, 4, and then halfway. So to determine this, let's just take 4.5 and times that by 2 pi, which we know 2 pi is one rotation around a circle, which will give us a distance of 9 pi, or excuse me, an angle of 9 pi. So substitute this information to find the arc length. We're going to multiply the radius times the angle, and that will give us a distance of 27 pi inches. This next example is a word problem. So a pendulum, now if you think of a pendulum, that's like a clock, or it's it, I guess, counts time. So I'm just going to kind of sketch something that would look like a pendulum. So I've got, this pendulum in here. It is 11 inches, and it swings 4 degrees 51 minutes to each side. So that means to this side, it is 4 degrees 51 minutes. And then to this side, it is also 4 degrees 51 minutes. Now you got one of two options here you can do. We can either find the arc length, half of the arc length first, and then once we find that, then just double it to give us the whole arc length. Or you could add these two angles together here and then find the total arc length. I'm just going to leave the angle as it is. But first, we have to change that angle from degrees to radians. So what we're going to do, because it's in degrees and minutes, we're going to just take 4 degrees 51 minutes in our calculator. We're going to multiply by pi over 180. Go ahead and put pi in the calculator and then divide it by 180, and we're going to get a decimal angle in this case, which is in radians, and that is 0.00148. Okay, so that's in radian form. Now I'm going to substitute in. We've got our radius is 11, and we're going to multiply by our angle in radians, which is 0.00148. That's going to give us an arc length of 0.9311 inches. Now that's only for this particular part of the arc. We need the whole arc. So what we'll do here is just multiply by 2 because it's doubled. And then that's going to give us an arc length of 1.86 inches. The last portion of the lesson here is, so we've just found the arc length around. What we're going to look at now is the area inside of that sector. Now you can think of this as like a piece of pie or a slice of pizza when we talk about the area of a sector. And you can read through this. The area of a sector is found by making up the fraction theta over 2 pi. So your angle over 2 pi of the circle. Just know that the formula here we're going to use is that the area of a sector will be 1/2 r squared theta, where theta is in radians. That's the key. So that means if theta is in degrees, we have to change to radians. So, and this, notice the caution here, it says the value of theta must be in radians. Because remember, radians is a real number when we're talking about distance around. So a center pivot irrigation system provides water to a sector-shaped field with the measures shown in the figure. So find the area of the field. So in this case, theta is 15 degrees. Now we need to change that. We're going to change that into radians. So what we'll do is use our pi over 180. I'm going to leave my angle in terms of radians. And if you divide, say 15 divided by 180 and change to a fraction, it's 1 over 12. So that angle in radians is pi over 12. Now we just substitute in. we know that 1/2, you can change that to 0.5. That'll just make it easier to plug into your calculator. 0.5 times the radius, well, our radius is 321, so we're going to plug in 321 and we're going to square it. And then times theta, which is pi over 12. To get the area, just plug everything into your calculator, even your pi, and you're going to get a decimal, but let's round to the nearest meter. In this case, we're going to have 13,488 meters square is the area of this sector in here. Our last example is a similar example. It's a center pivot irrigation system, provides water to a sector-shaped field. So again, you can think of it, here's our sector shape, our piece of pie or slice of pizza. It says find the area if theta is 40 degrees, and then the radius is 152 yards. So we're going to convert from degrees to radians again. So in your calculator, 40 divided by 180 converted to a fraction is 2 over 9. So this will be 2 pi over 9. Let's plug into our formula. And remember, the formula is 1/2 r, let me change that. 1/2, come on. Well, there we go. 1/2 r squared theta, where theta is in radians. So let's plug in. You can change that to 0.5. Substitute 152 where r is in squared, and then our angle 2 pi over 9. Plug all of that in your calculator and round to the nearest yard square. So 8,065 yards squared is our total area. All right, well, if you have any questions about any of the information, you will complete a quiz on this section, and just let me know if you have any questions. Thank you.